In the following video, we're going to examine 4 different examples on solving and graphing absolute value inequalities. We're going to look at both the less than absolute value inequalities and the greater than absolute value inequalities. Remember, less than absolute value inequalities create and compound inequalities, and greater than absolute value inequalities create or compound inequalities. So the first thing you want to do when doing an example, attempting an example, is look at which compound inequality is going to be created. If you have the absolute value of y minus 3 is less than 7, the first thing I would do is make a little note. Since it is a less than, we can mispronounce it as less than. And so now I know I'm going to deal with an and compound inequality. And remember, when you're dealing with an and compound inequality, your variable expression, which is y minus 3, the expression in the absolute value bars, is going to be between 2 numbers. And those numbers are based off of the idea that your distance of this expression is less than 7 units from 0. So we need to figure out what numbers are 7 units from 0. And so that is 7 and negative 7. And so we have our 2 boundaries. And again, remember, the way we solve this is we isolate the y in the middle. And whatever we do to the middle, we do to both outsides. So to get y by itself here, I'm going to add 3. So if I do it to the middle, I'm going to do it to both the outsides. And so that gives me the compound inequality. Negative 7 plus 3 is negative 4, is less than the negative 3 and 3 cancel, y, which is less than 10. So our compound inequality that we're going to graph over here is negative 4 is less than y, which is less than 10. So to graph this, let's just use the values negative 4 and 10. Our variable y is between them. Since they both are less than, they both are open circles. And the solution is between the 2 numbers. So the solution to the absolute value of y minus 3 is less than 7 is negative 4 is less than y, which is less than 10. You can think of it as y is between negative 4 and 10, and we can see that on the graph below. Let's look at another example. We have here the absolute value of 2x plus 4 is greater than or equal to 12. So here I see greater than, and so I mispronounce it as great or than. And so I know I'm dealing with an or compound inequality. So let's set up our 2 inequalities, our compound inequality from this. So our distance is greater than 12 units. So it goes beyond 12 on both sides of 0 and negative 12. So the first inequality is leaving it the same. You have 2x plus 4 is greater than or equal to 12. Or our second inequality, we use the same variable expression, 2x plus 4. Just like before, we're going to use the negative of our value because we're dealing with the distance of 12, which is both 12 and negative 12. But since we're dealing with the negative over here, and we're dealing with absolute value of an inequality, when you deal with an inequality and a negative, you have to flip the inequality symbol. And so now we solve these two individually. So 2x plus 4 is greater than or equal to 12. You would subtract 4 and get 2x is greater than or equal to 8. Divide by 2, x is greater than or equal to 4. 2x plus 4 is less than or equal to negative 12. Subtract 4, 2x is less than or equal to negative 16. And then divide by 2, x is less than or equal to negative 8. So our compound inequality solution set is x is less than or equal to negative 8, or x is greater than or equal to 4. So let's graph this on the number line below. So let's put a negative 8 value, and we'll go ahead and put a value of 4. The first says x is less than or equal to negative 8, so we have a closed circle on negative 8 with an arrow to the left. x is greater than or equal to 4 is in closed circle on 4 with an arrow to the right. So that is our example of absolute value inequality dealing with greater than. So we're going to examine two more examples. Here, it's a little more challenging. Just like when solving an absolute value equation, the whole goal is to get the absolute value isolated by itself first before you create the two equations. It's the same rule with absolute value inequalities. Before we can split this into our compound inequalities, we need to isolate this absolute value. So the first thing I'm going to do is I'm going to add 6 to both sides. I'm going to get rid of any addition or subtraction occurring near the absolute value. So that leaves me with 3 times the absolute value of 2x minus 4 is greater than 18. Same thing, I still need to isolate the absolute value by itself. So for this one, I am going to divide both sides by 3. So now I'm left with the absolute value of 2x minus 4 is greater than 6. So this is a greater than, so it's an or compound inequality. So let's create the two inequalities from this. The first, you just drop the bars and do 2x minus 4 is greater than 6. For the second, you have your expression 2x minus 4. We already dealt with 6 units from 0, so you have to go in the opposite direction, which is negative 6. And since I'm dealing with the inequality and I'm dealing with the negative, I have to flip the symbol. So let's solve these separately. I would add 4 and get 2x is greater than 10. And I would divide by 2 and get x is greater than 5. Here, when I add 4, I get 2x is less than negative 2. And divide by 2, I get x is less than negative 1. So my final solution set is represented by the compound inequality. X is greater than 5, or x is less than negative 1. So here's 5 in the number line. Here's negative 1. Since x is less than negative 1, it's an open circle with an arrow going to the left. X is greater than 5, open circle with an arrow going to the right. So just like when we solve absolute value equations that are a little tricky, we have to remember before we split it, before we create our two inequalities here, we have to isolate the absolute value by itself. So we have one more example along those lines. So we should be pretty confident with how to approach this one. Same idea, the absolute value of 4x plus 2, before it can be split into the two inequalities, has to be by itself. So what we're going to do first is we are going to add 8 to both sides. Get rid of any addition or subtraction. So that gives me 6 times the absolute value of 4x plus 2 is less than or equal to 42. Now I divide both sides by 6 and get the absolute value of 4x plus 2 is less than or equal to 7. So this is a less than absolute value inequality, so mispronounce it less than. So I'm going to create an and compound inequality. And so in dealing with an and compound inequality, remember your variable expression inside the absolute value bars is going to be between two numbers. And those numbers are represented by the distance. You know, we have 7 units from 0. So we know that 7 is 7 units from 0, and negative 7 is 7 units from 0. So to solve this, I'm going to subtract 2 from both sides. And I get negative 9 is less than or equal to 4x, which is less than or equal to 5. I divide by 4, so I'm going to divide by 4 on both outsides. So my final compound inequality is negative 9/4 is less than or equal to x, which is less than or equal to 5/4. To graph this one, negative 9/4 is between negative 3 and negative 2. And so now I'll go -1, 0, 1, and 2. So -9/4 is -2.25, so I'll put in a closed circle at -2.25. 5/4 is 1.25. And my solution set is between those two endpoints. So that is how we approach solving absolute value inequalities. Make sure the absolute value is isolated by itself first, then determine if it's an and or an or compound inequality, and break it apart and solve from there.